In the cold, distant corners of our universe, something enormous just happened. Two black holes, each hundreds of times more massive than our Sun, collided in a cosmic cataclysm never witnessed before. This is the biggest black hole merger humanity has ever seen, and it's rewriting the rules of physics. On November 23, 2023, gravitational wave detectors picked up an ultra-powerful ripple in space-time. It lasted just 1/10 of a second, but it was 20 times stronger than typical events. What did scientists find? A cosmic collision between two black holes, one weighing 100 solar masses and the other 140. Their merger created a single black hole 225 times the mass of our Sun. Why does this matter? Because current models say a single black hole formed from a star can exceed 100 solar masses. Yet here we are, seeing two massive ones that break the ceiling. According to Professor Mark Hannam, this event presents a real challenge to our understanding of black hole formation. In simple terms, the universe just threw us a curveball. These waves are ripples in space-time itself, predicted by Einstein over 100 years ago. But it wasn't until 2016 that LIGO detected the first one. Today, thanks to a global collaboration, LIGO in the US, Virgo in Europe, and KAGRA in Japan, we can track these cosmic tremors in real time. These black holes were spinning up to 400,000 times faster than the Earth. That's like spinning an object the size of a city block so fast that it warps time. This rapid rotation likely intensified the gravitational signal. The faster they spin, the more energy they release. Some scientists theorize this black hole pair wasn't born from collapsing stars, but from previous mergers. Imagine a cosmic family tree of black holes, each one bigger than the last. This hierarchy could lead to intermediate mass black holes, something long theorized but rarely observed. This discovery could open the door to brand new physics. Are we witnessing new black hole types? Could this affect how we understand dark matter, galaxy formation, or even the Big Bang? Researchers like Dr. Gregorio Carullo believe it may take years to fully decode the signal's meaning. AI is now helping astronomers analyze these fast, complex signals. The next generation of telescopes, like the Einstein Telescope or LISA, may reveal black hole mergers across billions of years. We're entering a golden age of gravitational astronomy. This black hole collision didn't just reshape space, it reshaped science. Every new gravitational wave we detect is a whisper from the universe's deepest mysteries. And we've only just begun to listen. What secrets will the next signal reveal? If you enjoyed this journey through the cosmos, hit that like button, subscribe for more space science deep dives, and drop a comment. What do you think created these black holes? Let's discuss.